Hello, this is Yetsnusi. I am going to show you how to solve this differential equation. This differential equation, by the way, this is called a Bernoulli equation. It's a nonlinear differential equation. Why nonlinear? Because we have here with order 2. It's a differential equation, first order nonlinear differential equation. Okay. Now, first thing you need to note. Sometimes you don't find this as y to the power of 2. You may find it y to the power of n. Okay. For example, you will find something like y to the power of n. Okay. First, n equal 2. This example. Okay. First thing, define v equal to y to the power of 1 minus n. In this case, it will be y, 1 minus 2. It will be y to the power of y minus 1. Okay, this is v. Okay, if we go back to our equation for this one, okay, could rewrite it y x times y prime plus y equal to minus x squared y squared. Okay, if you divide all by x, get y dash plus 1 over x times y equal to minus x y squared. Okay. Okay. As we said, we have n equal to 2 because this term, okay, this is called Bernoulli equation, by the way, this in this form. This is the form called Bernoulli equation. Okay. And now we will substitute, we define v equal to y to the power of minus 1 as we know here. Okay. And if you need to find y, will equal to this, by the way, v equal to 1 over y, so y equal to v to the power of minus 1. Okay, I hope this is very clear. Okay. Now we need to find dy by dx, because here this y prime is dy by dx. Okay. Okay, dy by dx, if you go to this equation, if you differentiate with respect to x, dy by dx will equal to minus 1 v to the power of minus 2 dv by dx. Okay, let me write it again in the next paper, the next page. We reach dy by dx will equal to minus v to the power of minus 2 dv by dx. Okay. Now we will substitute all these into our original equation, which is this case, which is this one, okay. So y prime will equal to, I'll rewrite the original equation, which is y prime plus, I think, 1 over x y, 1 over xy equal to minus x squared will equal to minus x y squared. Okay, if we substitute y prime by this term, will equal to minus v to the power of minus 2 dv by dx plus 1 over x times y. We defined y as this one here. Okay, so it is v to the power of minus 1. Okay, will equal to minus x y square, y, as we said, y equal to v to the power of minus 1, so y square will be v to the power of minus 2, okay? So I get this equation, we eliminate y, and we define another variable called v as a function of x, and we reach to this equation, okay? If we multiply both sides of this equation by minus v to the power of minus 2, so multiply both sides by this term, this means times, okay, we'll get dv by dx, left hand side minus 1 over x v will equal to x. So we reach this nice equation. Okay, we reach this equation. We got dv by dx minus 1 over x v equal to x. This is ordinary differential equation. Why we call this ordinary? Because we have only one independent variable, which is x. Okay, and v is dependent variable of x. Now we go for, we'll write it again, which is dv by dx minus 1 over x v will equal to x. Okay, this is first order ODE, ordinary differential equation. Okay, if we need to solve this kind of problem, this kind of differential equation, we go for some technique called integrating factor. Integrating factor. Okay, which is a very simple one. We will make some notation here. This is called p of x, some function of x, and this is called some function of x. This is the main shape of this integrating factor, plus some p of x times v, which is function of x for in our case, equal to q of x. Okay. Alright, so we need to go to find this integrating factor. We call it I will equal to e to the power of e to the minus of to the power of p of x d of x. Okay, which is equal to e to the power of p of x, which is minus 1 over x dx. Okay. Okay. The integration of this integration 1 over x dx will equal to e to the power of ln x minus ln x. Okay, if you know the rule for the natural logarithm, this will equal to ln x to the power of minus 1, because this minus you could go here if you can review the rules for the logarithms. Okay, so exponential to the power of ln will cancel each out, so will equal to x to the power of minus 1. This is the integrating factor. Okay. Alright, so we go for solving this type of problem. So our solution v of x will equal to, this v of x will equal to 1 over I, which is I the integrating factor, integration of q of x, the right hand side of our first order ODE, times the integrating factor by dx. Okay, the integrating factor, as we said, is x to the power of minus 1, so 1 over x to the power of minus 1 will equals to x. Integration of q of x, if you could review here, the q of x, the right hand side is equal to x times the integrating factor, which is 1 over x to the power of minus 1 d of x. This cancel each out, we'll get x dx. Okay. Okay, this is called x. Integration of dx will equal to x plus some constant c. So will equal to x times x plus c. This is v of x. Alright. Now we go back. V of x, what v of x, how we define v of x? We define v of x we define v of x here. V will equal to 1 over y. Okay, so we go back here, because both v of x and y are a function of x. Okay, so this 1 over y will equal x plus c. Alright, so y will equal to 1 over x plus c. Alright, this is our solution for our Bernoulli differential equation, and this y is a function of x. You can write it as like now for the same term. Okay, thank you for watching. I hope this video will be helpful for you, and I'll go for making some tutorials about how to solve ordinary differential equation which relate to integrating factors, and come with some examples of solving more nonlinear differential equation. So thank you for watching.